Einstein versus black holes. Let's light this fuse. We all know the headline. Black holes are so dense that even light can't escape. Relativity says nothing outruns light. Adding energy makes mass heavier as you approach that limit. But here's the twist. If energy and mass were perfectly one-to-one everywhere, a black hole should behave like a rocket revved to infinity. It doesn't. In my quantum physics model, that mismatch isn't a bug, it's the clue. The speed limit and mass gain are local effects caused by misreading one-thing field tension. First, the black hole parity, defiance. Add propulsion energy to a ship, and relativity says its effective mass skyrockets, trending to infinity as speed mirrors light. Yet a black hole can hold staggering energy potential without going infinite in the same way. It doesn't balloon in mass just because light is stuck. Why? Because it hits a saturation point in the Higgs field, the medium that gives particles inertia. In extreme tension, energy stops translating into motion or mass gain the way we expect. Second, light's escape is not about a cosmic fishing line yanking photons back. Think conductivity. Inside a black hole, Higgs-induced tension ramps so high that vacuum conductivity drops to zero. Light is the least interactive traveler, and if even light can't move, it's not being pulled. The road itself is gone. Zero flow state. Conduit closed. Third, propulsion mass gain is a labeling error. When a rocket accelerates, what you feel isn't your ship getting intrinsically heavier. It's the field tightening around it, induced resistance. Relativity reads that resistance as mass. Quanta says it's tension. Compare that to a black hole. Furious energy, but stationary, saturating the field instead of accelerating through it. So what breaks the stalemate? The parity neutralizer. If energy to mass were a perfect universal parity, a black hole's internal propulsion would nuke the neighborhood. It doesn't. That gap points to a key ratio of 4:1 energy to mass tuning that lets a craft match the smooth void, zero tension. Hit that state and you're not adding mass with thrust. You're sliding through a superconductive medium. The speed limit isn't smashed. It's sidestepped because the road friction vanished, and the singularity, not an infinite pinprick. Think conduit failure. The Higgs field has an elastic limit. Push density and core energy past that threshold, and the field doesn't bend forever. It snaps.
What if light and time don't get trapped at a black hole? They just run out of road. Picture the Higgs field as a universal conduit. It's the medium that lets light propagate and time tick, like rails for a train. Now crank space-time tension high enough and those rails snap. You don't get infinite gravity, you get zero conductivity. That edge is the event horizon. Not a pull you can fight, but a stall state. The conduit vanishes, so motion can't be expressed. Light doesn't lose, the track just ends. Inside that picture, the singularity isn't a place of infinite mass. It's a point of field absence, a structural failure of the conduit under extreme tension. And that twist reframes Hawking radiation. Mainstream says quantum effects let black holes slowly evaporate. In this model, the radiation is the Higgs field healing itself from the edges inward. The surrounding smooth void pushes to restitch the conduit. To do that, it reclaims energy from the saturated center. The byproduct? Radiation, as the field wins back territory from the failure zone. So evaporation isn't the hole disappearing. It's tension being neutralized. As the field heals inward, the region of total saturation shrinks. Eventually, the core can't keep the conduit snapped. The singularity closes. Space returns to a conductive state. Now, Take that insight to propulsion. If you know the tension limit where the Higgs conduit collapses, you can treat it like a safety boundary. Tune your craft's 4:1 energy-to-mass ratio to live in a superconductive zone, maximizing smoothness, never crossing into failure. A black hole is conduit failure by tearing. The technology is conduit optimization by smoothing. Same field, opposite outcomes. In practice, that makes the drive more than a motor. It's a field stabilizer. It prevents induced tension from ever reaching lag or fracture. And there's a wild implication. A massless profile craft skating that balance could polish the conduit as it passes, briefly making space more conductive for anything following in its wake. At the horizon, time and light don't slow because something is holding them back. They stall because the medium to carry them has vanished. Out at the edge, the universe doesn't shrug, it repairs. It pulls energy out, radiates it, and relays the rails. Trade infinite mass for finite field failure.